Good day, everyone. Today we are going to explore rational functions and how they are applied in real world scenarios. Specifically, we will focus on an example from photography, which is calculating the depth of field or the DOF. This concept is critical for photographers to control how much of their image is in sharp focus. So, what is the depth of field? Well, the depth of field is the distance in a photograph where objects appear acceptably sharp. It depends on several factors, including the aperture size, focal length, and the distance from the subject. The mathematical formula for the depth of field helps calculate this range. So, what is our formula? Well, our formula is the depth of field is equal to 2 times the aperture value multiplied by the circle of confusion multiplied by the square of the subject distance, all divided by the square of the focal length. So let's understand first what each variable means. Firstly, the depth of field. This is what the formula is solving for. The range in your image that appears sharp. Everything inside the depth of field zone will look focused, while objects outside this range will appear blurry. For example, in a portrait, you might want a shallow depth of field so that your subject is sharp, but the background is blurred. Conversely, in a landscape, you'd want a larger depth of field so that everything from the foreground to the horizon is in focus. Now, let's move to the numerator, the top part of the formula. First, we have n, or the aperture value. It is also known as the f-stop. It's the size of the opening in the lens that allows light to pass through. A smaller f-stop number like 1.8 or 2.8 means a wider aperture. This allows more light to enter but results in a shallow depth field, making the background blurrier. This is great for portraits or creative shots. And then a larger f-stop number like let's say 11 or 16 means a narrow aperture. This lets in less light but creates a larger depth of field, making more of the scene appear in focus. This is ideal for landscape or group photos. Next, we have C, or the circle of confusion. This is a technical term in photography that refers to how small a point of light can be on your camera's sensor and still appear sharp in the final image. And this depends on several factors like the size of your camera sensor, the resolution of your image, and how closely you'll be viewing the final image. In simpler terms, it defines the threshold between what appears sharp and what appears blurry in your image. Then next we have D. This represents the distance to your subject. So if your distance is closer to the camera, like let's say in a macro shot of a flower, the depth of field is very narrow and focusing becomes critical. And if your subject is farther away, like let's say you're taking a photo of a mountain in the distance, the depth of field increases significantly and more of the scene will appear sharp. Now, let's move to the denominator or the bottom part of the formula. We have f, or the focal length of the lens. It is one of the most important factors in determining the depth of field or the DOF. So a longer focal length will be a shallower depth of field, like let's say 100 millimeters or 200 millimeters, meaning the background will be more blurred. This is why telephoto lenses are popular for portraits. And then a shorter focal length, like 18 millimeters or 35 millimeters, creates a deeper depth of field, making it great for landscapes or street photography. For example, with a 50 millimeter lens at f1.8, your subject can be sharply focused while the background melts away into a beautiful blur, or known as bokeh in photography terms. Now let's apply this formula to a real life problem or a word problem. So our problem is Kevin, a popular influencer, is taking photos for a fundraising campaign to help build a clinic in a village. He wants to he wants the images to focus clearly on the clinic model in the foreground while blurring the background to make the subject stand out. Kevin needs to calculate the depth of field to ensure the clinic model is sharp in the photo. How much of the photo will be in focus based on his camera settings. So here is our values. So the aperture or the f number is equal to n is equals to 5.6. The circle of confusion is c is equals to 0.01 millimeters. The distance to the clinic model is d is equals to 3 meters. And the focal length of the lens is equals to f is equal to 35 millimeters. So the first step, we have to convert the meters to millimeters. Since the circle of confusion is in millimeters, we convert the distance from meters to millimeters. So 3 meters is equals to 3,000 millimeters. And then it's squared in the formula, so we will get 9 million millimeters. Step 2, just plug the values in the formula. So 2 times 5.6 times 0.01 times 9 million over 35 squared. And if you simplify that, that becomes 1,008,000 over 1,225. And if you plug that in the calculator, you will get 822.45 millimeters. So the depth of field is approximately 822.45 millimeters. So everyone, that is how you apply the formula. And thank you for listening.